Okay, this is question 2 from page 27. If you haven't watched the video for question 1 yet, I advise you do because it would make more sense to watch the video for question 1 because I kind of set the baseline of how to factor these trinomials with decomposition. So to start off, I want to find my product first. And in this case, my product would be the value of my first term, not including the variable, times the value of my last term. So in this case, 5 times 3, which happens to be 15. And my sum would just be the value of my middle term, not including the variable. So it would be 16. Now what I want to do is I want to find two numbers that multiply together to make 15, but add together to make 16. In this case, we only have a few choices. So I can think of 15 times 1 or 5 times 3 to make 15. But only one of these numbers would work when you add them together. So for example, 15 plus 1 equals to 16, and 5 plus 3 equals to 8. But because I want 15 and 16 to be my product and sum, I would say that 15 and 1 would be the numbers that I would want to use. So once I find out that these are the numbers I want to use, what I want to do from here is I want to rewrite my first term and my last term. But now instead of putting 16x as my middle term, I want to instead put the numbers that I found, 15 and 1. 15x and x as my two middle terms. And remember, I'm able to do this because 15x plus x does equal to 16x. So like everything's, I'm not breaking any rules of algebra. Now that I have it in this form, I want to consider these two numbers separately and these two numbers separately. And I want to try to divide out a greatest common factor from each of them. So let's say I consider the first one. 5x squared plus 15x. I believe 5 and x are common. So I would divide those out. And what I should have left inside would be x plus 3. And for my next term, I don't believe there is a greatest common factor for me to divide out. So I would just leave that as x plus 3. But now notice one thing. When I considered both those two sets of numbers separately, it seems both of them have one thing in common, x plus 3. So I'm going to put a bracket here. So that means I can divide out x plus 3 as another greatest common factor. So if I do that, I should be left with 5x plus 1. And it doesn't matter what order you do the, like once you find the numbers 15 and 1, it doesn't matter what order you do the, you kind of put them in. For example, if I wanted to, I could write 5x squared. It's my first term. I'll keep 3 as my last term, of course. But instead of putting 15x first, I could put x first and then write 15x next. And then I can consider both of these terms and both of these terms and try to find a greatest common factor again. In this case, x, I can divide out an x. So I should be left with 5, x plus 1. And for my second set of terms, well, I can't. I can divide out a 3. So I would be left with 5x plus 1. And in this case, 5x plus 1 is common in both. So I can divide out a 5x plus 1. And I should be left with x plus 3. Now notice that no matter which order I put either I put x first or 15x second or 15x first or x second, I still end up getting the same answer.